Hello folks, this is Tom from anti-proton.com, and I have conned my wife into being the camera woman. This allows me to actually talk and do stuff. Well, anyhow, I'm wearing my Soviet Olympics shirt, so God only knows what kind of amusing responses I'm going to get to that one. I'm sure I'll be declared now an agent of the Soviet whatever, but they don't even exist anymore, but whatever, who cares. I just get a kick out of that. I'll put up an online forum that states how many different things I must be secretly a part of. But anyhow, in reality, I'm just a really, really annoying nerd that likes science more than he probably should. Or am I? Today's topic is cosmic radiation. As I talk about cosmic radiation, I will have this Geiger counter on. Why do I have a Geiger counter? Who the hell doesn't have a Geiger counter? I assume everyone, because everyone must be just like me. I'm turning on this external sounder. The reason I have the external sounder on is so, there you go, you can hear it. I want you to be able to hear it the entire video. The reason I want you to be able to hear it the entire video is because we're talking about background radiation. And I need you to be able to actually hear the background radiation. So I'm going to put this over and keep the camera not on, don't point at the Geiger counter. Let them see how crappy the house looks, it's all messy. But anyway, I have the sounder so you can hear it the whole entire time. Okay, cosmic radiation. When you have a Geiger counter running, it ticks for some reason, even when it's not near anything apparently radioactive. Why is that? Is it radiation from Fukushima or even Chernobyl? No, of course it's not. Well, I mean, I guess theoretically could be, but not really. Majority of it is coming from space. If any of you watched my previous video, I bought 3 feet of lead from United Nuclear, a big piece of it, and I chopped it all up and I made this huge lead containment vessel to put my Geiger counter in, and lo and behold, it did virtually nothing to block out background radiation. Looking up on LND's website, because I have an LND Type 712 Geiger tube, I discovered that I require 2 inches of lead plus 6 millimeters of aluminum in order to stop all to reduce background radiation by 10 counts per minute. Crap, I have 14 counts per minute. That means I need like 3 inches of lead. That's how much background radiation is hitting us. Now, where's background radiation coming from? Well, here is the Earth. We are on this circle someplace. This white represents the cosmos in an undefined universe. There are all kinds of sources that are tremendous sources of radiation that are just coming down upon us all the time, and they just hit us randomly. There are these little things called pulsars. They send out radiation. They're actually collapsed stars, most likely. Stars who have squeezed so tightly that their actual very particles ripped apart to become their constituent point particles, which are incapable of getting smaller. And why are they incapable of getting smaller? Smaller. Because of the Pauli exclusion principle, naturally, which prevents any 2 particles of the exact same type and same exact properties from ever occupying the same space. Even at the point of black holes is this still taking effect. But whatever, look that up if you want in your spare time. Things like pulsars and our sun are sending out radiation, and they're bombarding us at all times of the day and night. Now, we have something interesting that comes off of our planet, the radiation belt here. See these lines of magnetic fields and everything they shoot out? And they protect us, the Van Allen radiation belt and so on. It protects us from radiation and particles as we spin through space. And as a result of it, that in altitude, you end up with all these varying levels of background radiation. As many of you know, when I took a recent airplane trip, I got 350 counts per minute on my Geiger counter only because I was at 36,000 feet. This tells you that the higher you are, the farther up in the atmosphere you go, the more radiation you pick up. Ironically, that tells you something too. That tells you the air is actually blocking a lot of the background radiation. Now, if I can only find the document I saw, it was on, I think, EPA's website maybe, or NASA, one of the 2. They were showing something kind of interesting. They were showing the altitude that you flew and the radiation that you detected, and they discovered that they did this. It went up. As altitude went up, radiation went up, which makes sense if what I'm saying is true, but then it curved and went down. Why is that? That makes no sense. Shouldn't it just kind of go in a finite sort of way? Well, this tells you something. This tells you that as radiation comes down, it's actually spreading apart to make other types of radiation. And that other types of radiation, the secondary radiation that you're getting, that right there is making a burst all of a sudden of additional radiation coming down upon you, which is what we're hearing right here. To give you an idea what this secondary radiation is that's hitting us all the time, you primarily have coming at you mostly protons, like antiproton.com. You have protons, which are these positively charged hadronic fermion particles. They are composed of 2 ups and 2 down quarks. If you're curious, look quarks up if you're curious about it. But anyhow, these protons, and there's a little tiny bit of alpha particles too. Yes, I know alpha particles are stopped by a sheet of paper and all, but the reality is in space they can have humongous amounts of energy to them, 50, 60 million electron volts penetrating power, and they don't hit anything, so they just kind of like fly on forever. So as these protons and other things are flying through here, they intersect what's called an incidence particle, or an incident particle, that happens to be moving along. That one's like doubled up. And it changes their trajectory a little bit. Not much, but you get that angle. Remember theta angle from trigonometry? Remember theta angle? And this particle has momentum. Remember momentum? Momentum is velocity and the magnitude of your go juice, your speed. Well, when you change, that must make a change in momentum. That change in momentum probably means a decrease of energy, right? And that decrease of energy, that energy has to go somewhere. Energy is conserved. It's neither destroyed or created. It just changes. The change in that energy will become a virtual particle, a chunk of energy that doesn't really exist per se. I mean, it does and it doesn't. But that will quickly formulate into a new particle, perhaps a high-energy beta particle or something else, just mesons and various other leptons besides the electron, other sorts of things. This is what's raining down on us all the time, and it's fine. It's okay that it rains down on us. Our bodies can take it. They have taken it for bazillions of years. I just got hit today by a 4 standard deviations higher than the norm, 34 counts per minute burst. And I'll put that up on my website later. I got hit by a 36 a couple days ago, and a 36 a couple days before that. Just random little spikes. Now, those may not be cosmic radiation. Hard to say what they are. But whatever they are, they were 4 standard deviations from my norm, which of course I calculate norms over thousands of counts. And they most likely came from space. That's cool and very, very interesting. But that's why your Geiger counter ticks more. The higher you go up in altitude, the more ticks you get. If I were up at, let's say, a mile up, I might be getting 50 or 60 counts per minute. But if I'm at sea level, I could only be getting 12 or 13. And if I went deep underwater, maybe even less. But that's the basic concept behind background radiation, and specifically cosmic radiation. It's coming from space, showers us from all directions. It's all throughout space, particles of interstellar matter. Some of it, as it comes in, even forms new elements as they fly through the atmosphere. Even high energy particles are hitting us, like lithium, for example. Pieces of lithium and carbon from space are flying in and zapping us all the time. So this is just some interesting stuff for you to think about, and be very, very thankful for the iron core that spins inside of the Earth that generates the magnetic field that protects us, because if we didn't have it, we would all be sterilized off the face of the Earth in minutes by the radiation. It's quite interesting that the people that are in space, the astronauts, are able to tolerate as much of it as they do. They have a decent amount of shielding, but there's a lot of it you just cannot shield. You cannot shield adequately things like neutrons and gamma with just a couple millimeters or even an inch of whatever material they have to stop. And God, apparently I must have just gotten hit by a high-power piece of cosmic radiation because I coughed my guts out. Of course, that's not actually true, but whatever. So in the end, that would be the end. And let me know if you have any comments or anything. Subscribe if you would like, and post comments. I like comments, including the amusing, aggressive ones, because they're always funny to laugh at. And come back here. Ah, cat ran away. I was going to show you the cat. This has been Tom from anti-proton.com. And as you can see, your current background radiation is 18 counts per minute. Bye-bye.